Module 15.5, Angle Bisectors of Triangles. Content Standard. Students will learn to construct, inscribe, and circumscribe circles of a triangle and prove properties of angles of inscribed quadrilateral. Language objective. Students will explain to a partner how to compare, contrast, describe, inscribe, and circumscribe circles. Applying the angle bisector theorem and its converse. The distance from a point to a line is the length of the perpendicular segment from a point to a line. You will prove the following theorems about angle bisectors and the size of the angle they bisect in exercises 16 and 17. Angle bisector theorem. If a point on the bisector of an angle, then it is equidistant from the size of the angle. Angle APC is congruent to angle BPC. So segment AC is equal to segment BC. So we're given that this is our angle bisector. So then we say that APC is congruent to BCP. So these two angles are congruent. Then we're saying that segment AC is congruent to segment BC. Okay, there's one more thing that I need you guys to take away from this is that segment PA is also equal to segment PB. Okay, so these two sides are congruent. Also that angle ACP is congruent to angle BCP. So then these two angles are also congruent. Converse of the angle bisector theorem. If a point in the interior of an angle is equidistant from the size of the angle, then it's on the bisector of the angle. So we're given that AC is congruent to BC, then angle APC is congruent to angle BPC. Right? So similar to the drawing on top, that we can conclude that PA is equal to PB, and also angle ACP is congruent to angle BCP. So then these two angles are also congruent, and these two sides are also congruent. Okay, example 1, find each measure. So here we're given that angle LJKM is congruent to angle LKM. So then that means that these two segments are congruent. So then JM is equal to LM. So then JM is given as 12.8. So then that means that LM is also 12.8. Example B, find the measurement of angle ABD. So we're looking for this angle here. And we're given that the angle ABC is 112, so then this is ABC, so this is given as 112. And then this is our angle bisector. These two segments are congruent. That means that these two angles are congruent. So then the measurement for ABD is equal to 112 divided by 2. So then it will be 56 degrees. Okay, always include the degree sign. Okay, now it's your turn to do number 4 and number 5. I'll give you a minute to work it out, and I'll give you the answer in a minute. Okay. Right. Okay, so let's try these. So use the figure for problems 1 through 4. Given that FG is congruent to HG, so then we go with the figure and we label what is given to us. FG and HG are equal to each other, and the measurement of angle FEH is given as 55 degree, and then this is a right angle. That means that these two angles are also congruent. So we're looking for GEH. So GEH, we're looking for this angle. That means that we're going to take 55 degree divided by 2. So it's going to be 27.5 degree. So I'm going to erase this to go on to number 2. Okay, so number 2, given that EG, so that this is EG bisect the angle FEH, so that means that now these two angles are congruent, and so this is an angle bisector, that's a right angle. That means that FG and HG are congruent. So if we're given FG is square root of 2, that means that HG is also square root of 2. Right. Okay, so let's go on to number 3. Given that the angle FEG is congruent to the angle GEH, and we're given that FG, so then this is an angle bisector, that's a right angle, so these two segments are congruent. So FG is 10Z minus 30, and HG is 7Z plus 6, and we are to solve for FG. So here we can set up the equation of 10Z minus 30 equal to 7Z plus 6. Now combining like terms, so then we're going to minus 7Z from both sides and plus 30 from both sides. So then this gives us 3Z equal to 36. So then that means that Z is equal to 12. But then we're not solving for Z, we solve for FG. Okay, so let me move up here. So then FG is equal to 10 times 12 minus 30. Okay, and then so then this is 120 minus 30, so then FG is 90. Right. Okay, so then we're going to erase this out to go on to number 4. Right, so number 4, we're given that FG is congruent to HG, and the angle GEF is given as A over 3A degree, and the angle GEH, so this angle here is given as 24 degree, and we have to solve for H. So that means that we're going to set the equation 8 over 3A equal to 24. So then to solve it, we need to do the reciprocal of 8 over 3, so times 3 over 8 from both sides. So that's reduced, that gives us A, and 24 into 8, that gives us 3, and 3 times 3 is 9. So then the value for A is 9. Right, so that's the end of our day 1 notes. Okay, so your assignment for tonight is to do number 2 through 5, and number 12 and number 13. And we have our new HRW, and you are to copy down notes for 15.2 day 2.